eli5 Does gravity act the same for large objects as it does for small objects? So if I were to shrink planet Earth and the Moon to say half the size and the distance between them, then would they continue orbiting? Would this also apply if they somehow became much larger? That depends on what you mean by large. If you mean diameter, then changing the diameter but keeping the mass constant won't change a thing. If you mean mass, then yes. Changing the mass will change the orbits. Mass and thus density are extremely important when it comes to gravity. You should explain your question better. Does the mass shrink, increase with the volume, or not? It really makes all the difference. If you look at the equation for calculating the gravitational attraction between two bodies, it depends only on the two masses and the distance between them. The Sun could be 10 times its current size or could be collapsed into a black hole. And we would orbit it just the same. We might be personally more or less happy with the living conditions. But a year would still be 365 and a bit days. There's actually a cool demo of this in Universe Sandbox. It has an example scene of some teacups orbiting a teapot. Works exactly the same as the Moon orbiting the Earth, only on a much smaller scale. The short answer is yes. Gravity is the same, but the different variables are not always proportionate. So if the masses were cut in half, that doesn't mean that the distance should be cut in half, or that the 29-day orbit of the Moon will still be 29 days or 14.5 days. For that matter, these may have to be different. So, if you double the size, you get 8 times more mass, 8 times more gravity. Distance. If you double the distance, you get 1/4 of the gravity. Double up everything keeping the same scale. 8 mass but 1/4 gravity, because distance equals doubled attraction between the two. Now, it works or not depending of Moon speed. Should be 0.35 of its actual angular speed. So 2.85 times more days to do an orbit. 80 days for an orbit. In a double all dimensions scenario. Don't forget to share, like and subscribe for more content.